Hello everyone. In this video, we will be discussing the concept of a junction entity. In the previous videos of this series, we have discussed the concept of UML and how to draw basic UML diagram. If you look at the previous video, there we had taken an example of showing the relationship between book and author. And there we assumed that one author can write n books, but one book will have only one author. So the relationship we depicted was of type 1 to n. So one author can write many books, but one book will be written by only one author. But in reality, if you see, there exist numerous books who are written by more than one authors. So the actual relationship should be one book can be written by many authors and one author can write many books. So this kind of relationship is actually n is to n, also depicted in crow notation as this. Now, nowhere in any UML diagram will you see a notation like this. This is possible, but we cannot directly represent this in database. Basically, many-to-many relationships cannot be implemented directly in relational databases. We will come to the reason why this is the case. But let us first understand the problem. So suppose that we have some books. For example, there is a book table where we have two columns. One is the book ID and one is the book name. And let's say the book number ID, we keep it as simple 1 and 2. And let's say book number is B1 and B2. Similarly, there is an author table as well, which also has two columns, ID and name. And let's say the IDs are 101 and 102, and names are A1 and A2. Now, if we represent this in a many-to-many relationship, do you see an issue? One author will have n number of books in its name. For example, 101 might have written both the books, B1 and B2. Similarly, 101 might also have written B1 and B2. That means both have co-authored B1 and B2. Similarly, for B1, I will write that both 101 and 102 have written this, and B2 will write both the authors have written me. The idea of normalization in database is that we have a concept of 1NF, where under first normalized form, you say that any column of database will have atomic value. No composite values are allowed. That means it can have any value like string, any number, any other value, but it should not be composite. If you look at these data types, they are list or array, and they are actually composite data types, not atomic. They are composed of atomic data types. There are two elements in this. And that's why we cannot represent any many-to-many relationship in any relational database. The answer is because of first normalized form, which only allows atomic values in the columns. So what is the solution? The solution is very simple. We introduce a junction entity. So we will write like this. Let's say I introduce a new entity, book author. This is a new entity. And this will have a relation like this. Book will have 1 to n relationship with book author. And author will also have 1 to n relationship. So now can you guess what will be the content of book author table? The book author table will have simply these values. One will be book ID and one will be author ID. Since book has 1 to n relationship with book author, then I can write like this, that book 1 was written by author ID 101. It was also written by author 102. Similarly, book 2 was also written by 101 and book 2 was also written by 102. That's what we discussed, right? If you look at this diagram and if you look at this table, they represent the similar things. Now, apart from these two columns, you can add more columns as well. For example, what is the royalty percentage? For example, author 1 is getting 40% royalty and author 2 is getting 60%. In book 2, both are getting 50-50%. So it is possible that you add more columns here. But this is the idea of a junction entity. Book author is an example of junction entity. Now you will say that in the Java program or any program, I will write like this list of books and list of author. Then what happens? When I save to the database, they are directly saved. But the part is, this is in object oriented terms. You write it in the program. Now there is a database layer, and connection between object oriented world and the database layer is the ORM tool, object relational mapping. For example, Hibernate. In, and in Hibernate, you can write the logic to convert these entities or these values, these lists to atomic values, and they will be saved like this. So to end user, to a developer, it won't matter because they will be writing list of book, list of author. But when they go ahead and save to the database, they will be converted automatically to atomic values. So when you write a query like this, for example, book.getAuthors. So you are trying to get all the authors for this book. Internally, ORM will convert this Java query to SQL query like this. Select star from author A, join with book author BA on A.id equal to BA dot author ID, where BA dot book ID is equals to whatever value you provide. Here it is book, let's say. So you will get, if I pass B1 dot get authors, it will give me authors 101 and 102. So in this video, we discussed the concept of end-to-end relationship and how do we represent them with the help of junction entity. We also discussed how the relationship between object-oriented world and the database world is mapped through ORM, where in the object-oriented world, you are free to use the list or the composite data types. But in database world, ORM handles the complexity for us by converting those composite objects into atomic values. We also took a look that junction entity might have different attributes as well. For example, royalty percentage, and how a Java query is converted to a SQL query. So that's all for this video. This was the concept of junction entity. If you are liking the videos in this series, then give a thumbs up and please consider sharing it with your friends. If you are finding any topic which is hard to understand, please let me know in the comment section and I will create a video on that. Till we meet again, thank you so much.